Welcome to the debate. Imagine waking up to a notification on your smartwatch. It doesn't just tell you how you slept. It actually tells you that based on the cadence of your walk, the temperature of your wrist, and, your zip code, you have an 88% chance of developing severe insulin resistance in exactly 3 years.
Which is a terrifying way to wake up, honestly.
Right, but the crazy part is this isn't based on a blood test. It's based entirely on an algorithm reading the invisible signals your body puts out every second. So today, we are looking at the massive integration of artificial intelligence with multimodal biological data.
Yeah, we're drawing on some really fascinating recent source material covering AI body analytics, metagenomics, and, well, what the scientific community is now calling the AI prevention era.
Exactly, but it brings up a huge question. Does AI's capacity to cross-reference these massive, multidimensional data sets genuinely democratize healthcare? Like, does it create a universal predictive model for preventing disease?
Or, and this is where I come in, do inherent biases, data poverty, and just the sheer mathematical chaos of biological noise risk exacerbating global inequalities? I mean, are we just driving over medicalization and creating an illusion of precision?
Well, I will be arguing that AI successfully harmonizes these totally disparate data streams from our genetics to our daily steps into a really robust, globally scalable engine for preventive vitality.
And I'll argue that severe structural data inequalities and just the dimensional chaos of human biology critically undermine its reliability as a universal equalizer.
Okay, so to really grasp this, we have to start by recognizing just how much information the human body actually produces. We often think of our health as just a few isolated numbers, right? Like blood pressure, heart rate, cholesterol.
The standard physical.
Exactly. But the reality is a ceaseless torrent of interconnected data. We're talking about your heart pulsing 100,000 times a day, your blood glucose fluctuating hundreds of times, 3 billion base pairs of genomic data in your DNA, and a gut microbiome teeming with, 39 trillion organisms?
Yeah, it's staggering. And historically, if a doctor wanted to look at all this, they hit a mathematical wall known as the curse of dimensionality.
Spot on.
And just for those who might not be familiar with that term, the curse of dimensionality happens when you have way too many variables and not enough individual samples to make sense of them. If you have a spreadsheet with 100 patients, but each patient has 10 million data points from their genome and their wearables, traditional statistics literally break down.
They completely buckle under the weight.
Right, you just can't separate the signal from the noise.
But that's my point. Modern AI architectures, specifically things like multimodal transformers and graph neural networks, they actually conquer this dimensionality. Transformers are brilliant at connecting the dots across sequential data over time.
Okay, but
Hold on, let me just graph. Neural networks can map out the complex web of biological pathways. They turn that chaotic noise into absolute clarity. And the stakes here are enormous. The Lancet estimates that by shifting medicine from a reactive stance, waiting until you're sick to treat you, to a predictive one, we can avert 40% of preventable deaths.
40% is a huge claim, though.
But we are already seeing it in action. Platforms like Tempus AI are cross-referencing tumor genomes with electronic health records and wearable data for oncology patients. And they are seeing massive survival boosts. Plus, through technologies like federated learning, these insights are scaling across massive public health networks like Brazil's SUS system. So AI isn't just another medical tool, it's a fundamental translation engine for human biology.
Okay. I agree that the sheer computational feats are undeniably impressive. But the foundation this entire predictive house is built on has severe structural flaws. You used the word global engine, but we are facing a profound reality of data poverty.
Data poverty?
Yes. 3 billion people across the planet are effectively excluded from the digital health footprint entirely. And the data we do have is heavily skewed. 80% of our foundational genomic and predictive data is skewed toward Caucasian populations.
Well, we are working on.
Let me finish this point, because if you look at bacterial DNA analysis for the microbiome, 90% of the databases skew toward gram-negative bacteria, which structurally respond to entirely different drugs than gram-positive bacteria.
Right, they have a different cell wall structure.
Exactly. So when you try to take this heavily skewed foundation and ask an AI to decipher messy, heterogeneous inputs, say, trying to compare a basic handwritten blood assay from a rural clinic in Kenya to a high-fidelity, terabyte-sized genomic sequence from a lab in Tokyo, you are introducing dangerous, invisible mathematical assumptions into the model.
I don't think they're invisible.
They are to the average clinician. We risk building a computational house of cards that doesn't democratize health at all. Instead, it creates synthesized, unrepresentative patterns that look scientifically valid but are actually just statistical illusions.
Wait, let me make sure I am following this, because I really want to tackle that foundational issue of the data itself head-on. You're basically saying that because the raw data is so complex and varied, the AI is hallucinating patterns that aren't really there.
Essentially, yes.
But I argue that AI pre-processing completely neutralizes that biological noise. Let's look at raw DNA sequencing data, right? When a machine reads your DNA, it's incredibly noisy. It makes errors.
Oh, absolutely.
But tools like Google's Deep Variant, they don't just use standard math. They actually translate the genetic sequence into an image. And then they use the exact same image recognition neural networks that self-driving cars use to spot stop signs to spot the typos in our DNA.
Wow. The self-driving car AI.
Yeah, and it does this with 99.9% accuracy. It isn't guessing, it is learning the exact structural reality of the data.
Okay, I don't dispute the Deep Variant is a brilliant piece of engineering. For cleaning up a genetic sequence in a controlled environment, it's great. But learning from what data? If the baseline images it learned from are fundamentally homogeneous, its accuracy is only 99% accurate for that specific demographic slice.
But we are expanding those baselines to millions of global samples. And when we move from genetics to everyday physiological data like heart rates and blood sugar, the mathematical harmonization is just as robust.
Is it, though?
It is. We use tools like principal component analysis, or PCA, which is essentially a way for the AI to find the most important ingredients in a massive, messy recipe and simplify them. Combine that with LS teams, long short-term memory networks, which are designed to remember patterns over a long sequence of time, and you get staggering results. Look at the 2024 Mayo Clinic study from our source material.
Right, the wearable study.
Yeah.
They used an LSTM network to ingest continuous glucose monitor data and 2 weeks of basic wearable data. Just steps, heart rate, sleep. From that alone, the AI accurately predicted the Matsuda index with 88% accuracy.
And we should clarify what the Matsuda index is, because it's important context. It's a highly specific measurement of insulin resistance. Normally, to get it, a patient has to sit in the lab for hours with IVs pumping insulin and glucose directly into their veins for a clamp test.
Exactly. It's an incredibly invasive, expensive, lab-bound test, and the AI predicted it with 88% accuracy just by looking at a smartwatch and a glucose patch across populations in the US, Europe, and Asia. I mean, the math absolutely works. You step out of that tightly controlled environment and into the real world, that democratization argument starts to shatter.
How so?
Well, I question the reliability of these mathematical harmonizations across disparate global formats. You're talking about taking patient records from the Epic software system in the US and trying to map them perfectly to Europe's TrackCare system. You're trying to align a highly sensitive medical-grade wearable with a commercial Apple Watch or a $50 fitness tracker.
But the algorithms are designed to handle that exact variance.
They handle it by forcing the data to fit. When AI uses techniques like that PCA you mentioned to reduce variance, or when it uses GANs, generative adversarial networks, it's actively intervening. A GAN is basically an AI playing a game of cat and mouse with itself to generate highly realistic synthetic patient data to fill in the blanks where real data is missing.
Right, to impute the missing values.
Yeah, but to do this, it often has to standardize this messy data using things like z-scores, grading everything on a standardized mathematical curve. The danger here is that the algorithm is mathematically forced to synthesize patterns to make the Apple Watch data look like the medical-grade data. It might draw a beautifully clean curve on the doctor's screen, but it is synthesizing a biological pattern that simply does not exist in the patient's actual physiology. It's the illusion of harmonization.
I see why you think that. But let me give you a different perspective. Think of AI pre-processing not as erasing differences or forcing a fit, but it's tuning a massive global orchestra.
An orchestra?
Yeah. Yes, the instruments differ. A medical-grade monitor and a commercial fitness tracker have a different timbre, but the underlying biological harmonies are universal once they are calibrated. We have tools like BioBert, which is an AI specifically designed to translate completely different medical text formats into one unified language.
Okay, for text, sure.
And for signals, we have wavelets, which acts as mathematical filters to strip away the static noise from a wearable device. The AI acts as the conductor. It translates both the Apple Watch and the medical wearable into the exact same sheet music. The fundamental biology of how cellular inflammation leads to insulin resistance doesn't change just because the data was captured on a cheaper device. The AI is learning the underlying physiological interaction, not just memorizing the instrument.
I come at it from a different way. The biology might be universal, but the manifestation of disease is profoundly shaped by environment, genetics, and resources, which logically shifts us from the theory of this mathematical tuning to the reality of how it deploys in under-resourced populations.
Okay, let's talk about deployment.
You've positioned AI as this great democratizer. But to patch the data poverty we discussed earlier, the industry is increasingly relying on proxy data. They'll use cell tower mobility data to predict community health trends, or they will literally use those GANs to generate synthetic South Asian metabolic profiles because they don't have enough real ones. Relying on synthetic data or mobile proxies to guess a population's health is a dangerous substitute for building actual healthcare infrastructure.
I'm not convinced by that line of reasoning because it completely ignores the reality of frugal innovation and edge AI, which are proving right now to be massive democratizers.
Frugal innovation?
It serves 5 million people. It uses a standard smartphone camera to detect microscopic changes in the person's skin tone as a proxy for jaundice and diabetes risks.
Just from the camera?
Yeah, it actually analyzes the color gradients on the camera lens, and its LSTM model outperforms standard World Health Organization criteria. Or look at Kenya's mHealth AI. They fuse basic motion data from a phone with simple SMS-reported vitals, and they cut preterm births by 18%. This isn't synthetic data. This is real-world, ground-level data collection made possible by AI.
But look at what you just described. Frugal innovation is a wonderful concept in theory. But when you use a smartphone camera to detect jaundice, because a population lacks basic blood assays, you are institutionalizing a two-tiered health system.
I wouldn't call it a two-tiered system.
It absolutely is. The wealthy get comprehensive, multimodal biomarker analysis with perfect accuracy, and the poor get an algorithm guessing their bilirubin levels from a low-resolution photograph.
But they get a highly accurate guess that saves lives rather than getting nothing at all. And remember, I mentioned federated learning earlier. Let me explain how that fundamentally solves the scaling issue. Imagine a recipe.
Okay.
Federated learning allows a local hospital to train the AI model on its own local, diverse patients. The model learns the new patterns, and then it sends only the updated recipe, the algorithmic gradients, back to the global server. It never moves the raw patient data. This means it fully complies with strict privacy laws like GDPR in Europe or the LGPD in Brazil. It allows global models to learn from local nuances securely.
Right. Federated learning is a brilliant privacy shield, yes. But it requires high-fidelity data to learn from in the first place. If a local hospital in a low-resource setting doesn't have the sequencing machines to generate the metagenomic data, if they can't afford the $100 per sample shotgun sequencing that blasts a microbiome sample into tiny pieces to map every single strand of DNA, there is no high-fidelity data to federate. The global recipe still only optimizes for the wealthy populations that produce the richest data.
But aren't massive global initiatives actively dismantling this imbalance? We have the Global Microbiome Conservancy. We have Nigeria's H3 Africa initiative, which is specifically cataloging underrepresented genomic data, like they're uncovering hypertension genetic variants that are unique to the Yoruba people.
Which is incredible work, yes.
Right. So if these predictive models are continuously retrained on this influx of diverse data, why do you view the statistical skew as a permanent structural flaw rather than just a temporary hurdle of scaling the technology?
Because the technological deployment aggressively outpaces the data collection. By the time the H3 Africa data is fully sequenced, vetted, and integrated into these massive multimodal transformers, the foundational models like Google's MedGemini or DeepMind's AlphaMissions have already set the clinical standards. They've already established the predictive thresholds and treatment protocols based almost entirely on Western data. We are baking the imbalance into the predictive architecture of the future.
I think that severely underestimates the adaptability of AI. These aren't static textbooks, you know? The models are dynamic. They use reinforcement learning to constantly update their weights and thresholds based on new real-world evidence, which really brings us to the ultimate question of this debate.
Let's hear it.
Assuming we can collect the data and the AI can continuously correct its baselines, does this immense predictive power actually improve human lives? Or does it merely create new anxieties and drive unnecessary medical treatments?
I am deeply concerned about the latter. We are rapidly entering an era of predictive alerts. I want you to really think about that smartwatch scenario you opened with.
Okay.
Imagine getting a notification on a Tuesday afternoon telling you your resistance index rose 5% because of your weekend carbohydrate intake. That level of hypersurveillance induces widespread anxiety and massive false positives. We are looking at a severe clinical risk of over-medicalization.
I don't see it as over-medicalization.
Our source material explicitly warns that, quote, not all resistance needs drugs. Yet, what is the immediate clinical reflex we are seeing? Hospitals are using these AI risk stratifications to preemptively prescribe potent pharmaceuticals like GLP-1 agonist drugs like Ozempic to high-risk individuals before they even develop a disease. We are taking complex, socio-environmental health determinants like food deserts, poverty, or chronic urban stress and reducing them to individual AI nudges and pharmaceutical prescriptions. It fundamentally oversimplifies what human health actually is.
I have to push back there. The clinical benefits of secondary and tertiary prevention, catching a disease before it ravages the body, far outweigh the risk of user anxiety. The UK's NHS AI Lab is using these predictive models to identify hidden risks, preventing 100,000 heart events yearly just by prioritizing statins effectively.
100,000?
Yes, 100,000. And in the realm of metabolic health, a recent Lancet meta-analysis showed that AI detection averts 40% of diabetes cases, strictly through targeted lifestyle nudges, not just drugs. And regarding the fear of black box algorithms just spitting out scary alerts, explainable AI, or XAI, is completely changing the game.
Explainable AI is supposed to show the doctor how the algorithm reached this conclusion, right?
Exactly. Tools like SHAP and Lyme don't just give a patient a scary risk score of 88%. They demystify the score. Think of SHAP values like analyzing a basketball game.
Okay, sports analogy, I'm with you.
It doesn't just tell you the final score. It calculates exactly how many points, rebounds, and assists every single player contributed to that final outcome. In medicine, SHAP isolates the variables. It tells the clinician, this specific patient's risk is elevated primarily because of a lack of a specific gut bacteria, combined with a recent spike in LDL cholesterol. It shows the exact biological drivers. That builds incredible clinician trust and targets the treatment.
That is a very compelling way to frame it. But have you considered how those specific biological drivers are interpreted in the reality of a 15-minute clinical consultation?
What do you mean?
When an AI dashboard highlights gut dysbiosis in bright red as a primary driver, the immediate reflex in our current medical paradigm is to prescribe a targeted intervention. Maybe it's an engineered probiotic or a microbiome-modifying drug. We end up pathologizing every minor deviation from the AI's mathematically derived ideal state. When we track biomarkers continuously, every single physiological fluctuation becomes a medical event to be managed. We start treating the algorithm's alerts instead of the human being.
That's an interesting point, though I would frame it differently. If explainable AI clearly delineates the specific probability of progression, doesn't that precision actually prevent over-medicalization? It allows doctors to target interventions only where they are biologically necessary. Think about it. Without AI, a doctor sees an entire demographic of pre-diabetic patients and might put all of them on preventative medication just to be safe. With AI, the doctor can see that a specific subset of those patients has a visceral fat-driven resistance subtype that responds entirely to dietary nudges, sparing them the pharmaceuticals. The AI allows us to see that a low presence of Akkermansia bacteria in the gut is the true signal of resistance for another patient, and we can address that precisely with diet. Precision is the absolute antidote to over-medicalization.
Precision is only the antidote if the healthcare system is actually incentivized to prioritize lifestyle over pharmaceuticals, which globally it often is not. Furthermore, the precision you are talking about relies entirely on the assumption that the biological noise we discussed earlier has been perfectly filtered out. If that SHAP value is emphasizing high LDL cholesterol based on a wearable's imputed synthesized proxy data rather than a clean laboratory blood draw, the doctor is making a hyper-precise, life-altering medical decision on a foundation of statistical guesswork. It gives the physician the illusion of certainty.
I simply wouldn't call it guesswork when algorithms like gradient-boosted trees are detecting atrial fibrillation from 400,000 ECGs with 98% accuracy. The math is proving itself in the field, but we are reaching the end of our time, so let's synthesize where we stand.
Sounds good.
I maintain that AI cross-referencing, fusing everything from genomic variants and continuous glucose monitors to wastewater epidemiology is an unprecedented leap forward. It represents a monumental shift for humanity. We are finally moving away from the costly, inefficient, and tragic model of treating sickness after it destroys the body. Instead, we are harmonizing a global symphony of predictive vitality. It empowers every human data point to contribute to a resilient, proactive healthcare system.
And I maintain that while the technological mapping of the human body and the microbiome is undeniably an extraordinary scientific achievement, we cannot ignore the scaffolding holding it up. The reliance on inherently noisy, heterogeneous data and statistical baselines derived from a deeply unequal world means we must approach this predictive era with profound caution. If we mistake algorithmic imputation for biological truth, or if we accept frugal proxies as a substitute for genuine health infrastructure, we risk encoding our existing structural disparities into the very fabric of future medicine.
Yet, I think we both clearly acknowledge that AI's ability to fuse multimodal health data is permanently redefining our understanding of biological interconnectedness. Whether it's platforms like Blue Dot tracking antimicrobial resistance genes in city wastewater, or graph neural networks decoding the incredibly intricate signals of the gut-brain axis, the fundamental paradigm of how we view human biology has changed forever.
Oh, absolutely agreed. The sheer computational capacity to map out how a lack of sleep elevates cortisol, which then spikes blood sugar, strains the heart, and simultaneously alters the gut microbiome. That orthogonal insight is completely revolutionary. The disagreement remains on how reliably, safely, and equitably this technology can actually be deployed across the globe.
Exactly. And that is where we will leave it for today. We invite our listeners to consider how their own daily data, from the heartbeats logged on their watch to the dietary choices that feed their microbiome, factors into this massive, complex global health puzzle. Think back to that opening image. Is your biological data just a solitary instrument playing in the dark, or is it becoming part of a tuned universal symphony? There's so much more to explore in the source material on this. Thank you for joining us on The Debate.